Okay, so for this lesson, we're going to be looking at 3D applications of sine law and cosine law. And we've talked about cosine law on its own, and we've talked about sine law on its own, and we've talked about our primary trig ratios on their own. And the word problems we've used always have 2D diagrams. So we're going to take this one step further and look at some 3D diagrams. I'm going to apologize in advance for my drawings. I'm going to do my best to make them look okay, but it's really hard to draw a 3D image on 2D surfaces when you are not a particularly great artist. So there are a few important things to remember when we're solving word problems. The first one is to sketch a well-labeled diagram if appropriate. For a word problem, it's very seldom that a diagram is not appropriate, so please sketch a diagram. Even if you are on a quiz and you get everything else wrong, if you have a diagram, I can help you out with it, and I can at least give you some part marks. If you make conclusions from your wrong diagram, I can at least use that to give you part marks and see what you understood from the question. So please draw a diagram. Next, we're going to choose an appropriate strategy to use. So all of our trig strategies are fair game here. So we could be using our sum of our angles. So remember that all of our angles in a triangle add up to 180 degrees. We can also use the Pythagorean theorem. So remember that this is only for right triangles. We could also use SOHCAHTOA. Remember that is also for right triangles too. And then we have sine law or cosine law. If you accidentally used sine law or cosine law on a right triangle, it works out fine. But if you accidentally use SOHCAHTOA or Pythagorean theorem on a triangle that is not right, it doesn't work. They only work because of the 90-degree angle. That's what makes them all true and makes it so you can use them. So please be careful about that. And finally, make sure you have therefore statements. That's what conclude means. So when you have a word problem and there's words in your question, make sure you have words in your answer. Okay, let's get into some examples. So I've drawn a bit of a diagram here just to help you out. But what we're going to do is we're going to break it down a little bit further to make it a little more clear. So from point M, which I have labeled right here, Melissa uses a clinometer to determine the angle of elevation to the top of a redwood tree as 67 degrees. Now what a clinometer is you may have made one in elementary school, but it's basically this device that I can look out straight at something and look straight up and measure the angle that my head tilted up. So in other words, measure my angle of elevation. For the purposes of this question, we're going to assume that she's measuring her angle of elevation from the ground. But if you get a question on a quiz or one of our unit tasks and you're not sure if it's measured from the ground, that is always a fair question to ask. So Melissa measures her angle of elevation from the ground looking up at the tree as 67 degrees. So that's where that angle goes. Now, Bobby is standing 38 meters away from Melissa. So now we know that we have Bobby over here, and he is 38 meters away from where Melissa is. He now estimates that the angle between the base of the tree, himself, and Melissa to be 26 degrees. So he figures out that this angle is 26 degrees. So the wording here is a little challenging. So the angle that connects Melissa and the base of the tree and him in the middle is 26 degrees. Melissa estimates that the angle between the base of the tree, herself, and her classmate Bobby is to be 57 degrees. Here 57 degrees. Like that. What is the height of the tree to the nearest meter? So a few important things to note. These here are right angles. And they're right angles because when I have an angle of elevation, I'm looking straight at the base of that tree, and then I'm going to move my head up. And I'm going to move it up along this straight line here. So that has to be a right angle. And now what we're going to do is we're going to separate this into some different triangles so we can look at different triangles at once. So I'm going to start with the triangle at the bottom here. And we'll make that an orange triangle. And what I'm going to do is I'm going to draw these triangles out separately. And the reason why I'm going to do that is so that we can do all the math for each triangle individually. And if I try to do it all in one diagram, it just starts to get really busy really fast. So here's our first triangle. There we go. And we have 26 here, 57 here, 38 meters, and B. Now, what we want to do is we want to figure out what information we can get from this middle triangle. So because I have 2 out of 3 angles, I always want to find that third angle here. So to do that, I'm just going to do 180 minus 57 minus 26. So that will give me an angle of 97 degrees. So in here is 97 degrees like this. And I'm also going to add these in to my other diagram here just so I can keep track. Now what I want to think about is what other information do I need to know to find the height of this tree? So I'm going to look at one of my other triangles here. Let's look at this triangle on the side here. And the reason I'm picking this one is because I have that 67 value. So I'm thinking maybe that one can help me out. So let's draw that triangle over here. There we go. And on this triangle, we have 67 degrees and X. So what we want to start thinking about is what could I find on my orange triangle that would help me out on the pink triangle? So if I look here, there is one space where they share. They both share this line here. So if I could find the value of this line, it would give me this. So because it's the one point they share, that's telling us that it's going to be a good starting point for us. So let's solve for that line, and let's just call that line Y for right now because we already have an X as the height of our tree. So now what we're going to do is we're going to look at the orange triangle and we're going to figure out which of our tools can we use to solve this. Firstly, it's not a right angle triangle. So Pythagorean and SOHCAHTOA are out. Next, we're going to look and see if we have enough information for sine law. If we have enough information for sine law, it's sine law. If not, we're moving to cosine law. There are some other ways that you can determine which one it is. So for example, if you knew, okay, I have side, angle, whatever combo of letters helps you to remember it, you can also do it that way. But I find it easiest to look for my full pair and my half pair. So to start, I have a full angle side pair here with the 97 and the 38. And I have my half pair with this side I'm looking for and this 26. So now what I'm going to do is I'm going to set up my sine law equation. So because I'm looking for a side length, I'm going to put the side lengths in the numerator. So we'll have Y over sine 26 equals 38 all over sine 97, like this. And now we want to isolate Y. So y is currently being divided by sine 26. So we're going to multiply that side by sine 26. And we're going to multiply that side by sine 26. So that leaves us with y equals 38 sine 26 all over sine 97. And I'm just going to put that whole thing in my calculator in an effort not to get any rounding error. 38 sine 26 divided by sine 97. And that will give me 16.8 meters. So again, I'm going to take that 16.8 meters and I'm going to put it in my original diagram just to keep track of it. I'm also going to put it here, and I can also put it on my pink triangle over here. So now let's use our pink triangle to solve for x. So if I look here, I have a right angle triangle. That's the first thing that we need to notice. And then I'm going to think, can I use Pythagorean theorem? And the answer is no, because I only have one side length. So what I'm going to do is I am going to use SOHCAHTOA. So I start by circling my angle and labeling my triangle. And we only label the sides that have things on it. So here's my adjacent side. Here's my opposite side. And because I have opposite and adjacent, that's telling me to use tan. So we'll have tan theta is opposite over adjacent. In this case, our theta is 67. So we'll have tan 67 equals x over 16.8. Now we want to get x all by itself. I'm just going to quickly do this and then I will get to your question. So Dimitri's asked, instead of SOHCAHTOA, can we use sine, cosine law instead? Absolutely, you can. That's a great question, actually. So you can use it for sure, and it works. The only piece is that sometimes SOHCAHTOA can be faster. So from an efficiency or time perspective, sometimes doing a full sine law or full cosine law question can just be kind of long. So if you're feeling tight for time on a quiz or on a task, sometimes it may be because you've picked the wrong thing, but you'll still get the same answer. So I would give you full marks for it if you did it that way. So now we have 16.8 tan 67. So I'm just going to put that into my calculator. And that will give me 39.6. So that gives me my height of my tree. So the last thing to get full marks is please write a therefore statement. So we'll say therefore the tree is 39.6 meters tall. Are there any questions about this at all before we move on to our next one? Then I'll probably do attendance after this. Any questions about any of the steps? No, we're okay so far? All right, so I'm going to quickly screenshot who's here for attendance, and then we can get on to our second example, which the diagram for the second one is a little tougher, so it will take us a moment. Okay. All right, so I'm just going to quickly screenshot who's here for attendance. Make sure I get everybody. I'm pretty sure we have everybody here, which is fantastic. Makes things easier for attendance. Okay, so let's go through our next example here. So the diagram here is a little tricky, so bear with me because we're going to break it down and make it a little bit clearer. So Julia is on a 50-meter high bridge and she sees two boats anchored below. From her position, boat A has a bearing of, sorry, some of the number there didn't print, so I'll just write it in. So boat A has a bearing of 230 degrees. So that's this pink line here that goes from north and around 230 degrees. That's what that bearing means. Oh, it's just over there. Thanks, Ethan. I definitely didn't even see that. Oh, okay, great. So it's there. Thank you. Then boat B has a bearing of 120 degrees. Julia estimates the angles of depression for boat A to be 35 and for boat B, 38 for boat A and 35 for boat B. How far apart are the boats to the nearest meter? So what we're looking for is we're looking for the length here. So what we're going to do is we're going to separate these triangles out to draw them all separately and try to understand what pieces of information that we're needing and what we can find. So to start, let's take this triangle right here and we're going to draw it over here. So this is our first triangle. And that is triangle A, E, Q here. Now there's a few pieces of information that we're given. We're given that the angle of depression is 38. So when I'm looking for an angle of depression, that means that her looking down at the boat would be 38 degrees. Now, there's a couple ways where we can get this angle into the triangle. We can start by finding E. So because those are two complementary angles, we will have 90 minus 38 gives us 52. So in here is 52. The other thing that we could do is we could also use the Z pattern here, which gives us that angle A is also 38. Either way works. Whatever you're more comfortable with will give us those values. So whatever is more comfortable for you to find your missing angles. So that's our first triangle there. Our next triangle is this triangle over here. We have a second right angle triangle on the other side. So let's go through and draw that one separately as well. So that would be triangle E, B, Q. And similarly, we know that this boat has an angle of depression of 35 degrees. So when she's looking straight out and looking down, she's looking down at an angle of 35 degrees. So what that means is that we have two ways to find our angle E. We can use the fact that they're complementary angles. So we can do 90 minus 35, which gives us 55. Or we can use our Z pattern again. That looks like this. And that would tell us that this one's 35. It doesn't matter which one you want to use. Whatever you're more comfortable with is fine by me. So as long as you get that that one's 35 degrees. Okay, so we have one more triangle left to find on its own. And that is this triangle down here. So let's draw that one out on its own. There we go. And that is triangle ABQ. And we're looking for that side there. That is our distance between our boats. So that's the one side that we really want to be mindful of that we're looking for. So there is a few missing values here. So if I'm looking at my angles, I have 120 to here, and then I have 230 all the way to here. So this little bit in the middle is the difference between those two. So this little bit here is going to be 230 degrees minus 120 degrees. So we can fill that in. And that would be 110 degrees in there. So now we need to start thinking about what pieces of information do we need to solve for that side x. So I definitely am going to need some side lengths because I don't have any side lengths to use in sine law or cosine law. Or maybe I could find some angles. So I want to start thinking about what I could find. So let's look on our diagram to see what sides are shared between our triangles. So if I look here, this side is shared, which is my bottom side here, and so is this side over here. So if we're able to find those lengths, then at least we can start putting some stuff on our orange triangle. So if we look at our pink triangle, we're going to start by circling our angle. And I'm going to circle angle A, but if you decide to circle angle E, that absolutely works too, and you'll end up with the same answers. If you want to try it on your own and prove that it works, absolutely go for it. You can, no problem. So now we label our triangle. So this is my adjacent side. This is my opposite side, like that. There we go. And now I have to make sure that I put my height of my cliff. I realized I forgot to put that in there. Sorry. And now we have opposite, and we're looking for our adjacent here, which I will call y. You can call it something different. So we're going to have that tan of our theta is equal to opposite over adjacent. So in this case, our theta is 38. Our opposite side is 50. And we're looking for side y. So we want to isolate y and get it all by itself. So we'll multiply this side by y, multiply that side by y. So we'll have y tan 38 equals 50. And again, to get y all by itself, we need to divide out that tan. So we'll get y equals 50 divided by tan 38. And that will give us 64. So that means right here is 64 meters, and I can put that into my orange triangle like that. Any questions so far before I move on to the green triangle? You're okay so far? Awesome. Okay, so we'll do the green triangle. Sorry, I'm kind of running out of room, so I'm just going to move the green triangle math over here. So again, we're looking for this one here. I'm just going to call it Z, so we have something in there to label. So again, I circle my angle. And if you want to circle the 55, that works too. Your answer might just be a little bit different than mine. So now I label my triangle, adjacent, and opposite. So we'll have that tan 35 equals my opposite, which is 50 over Z. And now I'm trying to isolate Z. So it's really hard to isolate a variable when it's on the denominator. So let's multiply both sides by Z. And then in order to further isolate Z and get it all by itself, let's divide out that tan 35. So that gives us that Z is equal to 50 divided by tan 35, which gives us 71.4 meters. So now here I have 71.4 meters, and I can put that on the orange triangle. Now if I look at my orange triangle, I'm going to look for x. So now I look at it and I think, do I have enough information to solve for x here? So if I try sine law, I don't have enough for sine law, but that's okay. But do I have enough for cosine law? I have two sides here, and I have the value of their interior angle. So that means cosine law question. So now I'm going to label my triangle, and I'm going to write out my equation for solving for little q here. So that will give me little q squared equals a squared plus b squared minus 2ab cosine of big Q. And now that I've labeled my triangle, filling in that equation is pretty straightforward. So we have x squared equals 71.4 squared plus 64 squared minus 2 times 71.4 times 64 cosine of 110. Now, like we had said on Friday, if you have a double-lined calculator, I would highly recommend plugging all of this into it. For those of you who don't have a double-line calculator, I'm going to go through and do each step. But if you do have a double-line calculator, just plug it all in. As always, if you don't know how to use your calculator, just let me know so that I can help you, because every calculator is a little different. So what I'm going to do is I'm just going to use BEDMAS. So if you don't have a double-line calculator, these are your steps. I'm just going to simplify my 71.4 squared, which is 5097.96. And do the same with the 64 squared. And then I'm going to multiply 2 times 71.4 times 6 times cosine 110. Oh, it looks like Mr. Kaufman is getting close to the answer, which is great. So we'll go through and verify it. So usually, Mr. Kaufman, we usually say raise hand first before we say our questions or our comments. And then, oh, that's okay. No worries. So I'm just going to simplify that. So I will get 3125.79. There we go. And now we'll simplify all of that. So we'll have 5097.96 plus 4096 plus 3125.79. And then if I look at this answer is way too big for my question, right? That doesn't make any sense. It's way too big. So now we're going to square root that. So we'll do square root 12319.75, which is 110.99, which we could round to 111, which for me, it's just rounding error because I typed everything out. So it turns out that Mr. Kaufman was super close, which is awesome. So that is our solution. And now, because we had a word problem and we have questions in our, Mr. Kaufman, do you have a question?
I have one question. I'm so sorry to interrupt the lesson. It's amazing.
Oh,
how do you raise hands in the class? Like,
we just type it. We just type raise hand.
I got you. All right.
Oh, yeah. No worries.
I'm going to leave now. Thank you. Bye.
Oh, bye. Thanks for your time. So when we have words in our question, we have to make sure we have words in our answer. So we need to have a therefore statement. Therefore, the boats are 110.99 meters apart. Okay, are there any questions about that? Because that's the last one. Are we good? Okay, so I think before somebody had brought it to my attention that I had the wrong homework problems on one of the earlier ones. So the homework problems should have been the ones on the trig identity. So there are these ones. Sorry, I changed the order of the lessons because I wanted to do trig identities in the morning. So yeah, exactly. I think it was originally I had that first, so that's what happened. Are there any questions before I send you off? Oh, great. Good for you. Now you have more time to practice other stuff. Not a problem. Okay. Oh, great. Thank you, Trig. I always forget about that. Okay.